we're going to work on calculating the data for the empirical formula lab here. So over here, here's a set of data that's a little different from what you have been provided with, but the way to do it is the same, okay? So molar masses of copper, water, and chlorine is provided also in the lab manual, but I just wrote it down here so we'll have it handy. Now, the first thing we want to get is mass of hydrated sample. Mass of hydrated sample is you take mass of crucible plus the hydrated minus the empty crucible's mass. So to get this answer, we'll do 17.2531 grams minus 16.1850 grams. This would be the mass of the hydrated sample. So here I get 1.0681 grams. Okay, this is mass of the hydrated compound. The dehydrated compound, which is this number, mass of crucible plus dehydrated minus the empty crucible. So again, I'll take 17.0297 grams minus 16.1850 grams. All right, let's try to do this one. .8447 grams. Okay, so to get mass of copper, we'll have to take watch glass plus copper minus the empty watch glass. So that would be 15.7818 grams minus 15.3732 grams. Get 0.4086 grams of copper. Okay, now to get moles of copper, simply take the mass of copper divided by the molar mass of copper. So over here, we'll take 0.4086 grams of copper, and we know that 1 mole of copper weighs 63.546 grams of copper. So do this here. We will get we'll keep 4 sig figs because this is 5 and this is 4. So 6.4, it's 2998, so I'm just gonna go out 430. Times 10 to the power of -3 moles. Okay, to get mass of water, we simply take the hydrated sample minus the dehydrated sample mass. So 1.0681 minus 0.8447. So let me write this out. 1.0681 grams minus 0.8447 grams. That gives me 0.2234 grams of water. Okay, now to get grams of water, we turn it to moles, we'll use the molar mass of water that's given up here. So let's continue. We'll take 0.2234 grams of water, and we know that 1 mole of water weighs 18.016 grams of water. And then let's see, let's get the moles here. 0.01240. I have 4 suffix, keeping the 4th number here. 1240 moles of water. All right, to get the mass of chlorine, literally you take the whole sample minus the water content and minus grams of water and minus grams of copper. Or you can take the dehydrated sample, which doesn't have water, and subtract the copper out. This will be the easier step because the dehydrated sample only has copper and chlorine. If you know how much copper there is, you'll know how much leftover chlorine. So I'll take grams of dehydrated sample, 0.8447 grams, minus grams of copper, 0.4086 grams. So over here, 0.8447 minus 0.4086 equals to 0.4361 grams of chlorine. In that case, let's convert it to moles of chlorine using the molar mass, 0.4361 grams of chlorine divided by the molar mass of chlorine, which is 35.453 grams of chlorine in 1 mole of chlorine. And see how many moles we get here, 35. We get 0.01230 moles of Cl. So now that we have the moles here, we can do the mole ratio. They want the first one to be chlorine over copper. So take the moles of chlorine divided by the moles of copper. So that would be 0.01230 moles of chlorine. The ratio of that to 6.430 times 10 to the minus 3 moles of copper. That's a little hard to see, so I'm going to divide this by copper. So basically take both sides, divide by the moles of copper, and that will turn into, obviously the copper will be turned into 1 since I divided by that same number. So both sides divide by 6.43, 10 to the minus 3. Okay, so that side for copper will be 1. So 1 copper. Let's take a look at what the chlorine will look like. So 0.01230 divided by 6.43 10 to the minus 3. And you'll get 1.913. And this is moles of Cl. Okay? Now, and then we'll have moles ratio of water. We'll do the same thing. So moles of water is 0.01240 moles of water, and divided by the same number for copper, 6.430 times 10 to the minus 3 moles of copper. Over here, we'll divide both sides by this value again. Then the copper will turn into 1 mole of copper, and we'll see how many moles of water that is. So we'll take 0.01240 divided by 6.430 to the times 10 to the power negative 3. I get 1.928 moles of water. So this is my ratio, 1.913 to 1, 1.928 to 1. And then it says for the formula here, it says don't do it like, you know how we divide by the smallest number of moles, and then if it's not quite the whole number, we have to do more steps in the lecture. But since it's lab, we have a lot of experimental error. All we do is we round these numbers to the nearest whole number, which would round it to 2 to 1. 2 chlorines to 1 copper, 2 waters to 1 copper. So dehydrated sample formula would be simply 1 copper is to 2 chlorine. So it's just CuCl2. If it's a hydrated compound, you'll have CuCl2, and then Cu is paired with 2 H2O. So your hydrated compound will be CuCl2 dot 2 water. This is how you write formulas for hydrated compound. You put a little dot and put the number of waters that's associated with it. I hope this helps.